we're going to look at titration curves for strong acids and strong bases first. A titration curve is a plot of pH versus the volume of acid or base added. Consider the titration of HCl with NaOH. That's a strong acid with a strong base. Before you add any base to the solution, its pH is 1, just by taking the negative log of 0.1, which is the concentration of HCl. I want to find the pH after I've added 10 mils of 0.1 molar NaOH to this solution. Well, in a titration problem, I need to determine the number of moles of acid and base present. So to find the moles, I'm going to take the concentration, which is 0.1, and multiply by the volume in liters. So 0.025 liters. So the amount of moles of HCl is 0.0025. Same thing for the base. I'm going to find the moles of the base that have been added. Concentration is 0.1. And the volume of the base is 0.01 liters. Okay, so I found the amount of HCl that I'm adding to the base. So here is my equation. HCl reacts with NaOH to form sodium chloride and water. At the start, I had 0.0025 moles of HCl, and for NaOH, 0.001 moles. We don't worry about water. The salt was 0. The change, well, the NaOH is going to get used up. So 0.001. So after the reaction, I have no NaOH present. The mole ratios are 1 to 1 to 1, so the change is the same for all species. So after the reaction, I have some HCl left. I also have some salt present after the reaction is complete between the acid and the base. Well, NaCl is a salt produced from a strong acid and a strong base. So the salt is neutral. It does not affect the pH of the solution. The only thing that's going to affect the pH is the amount of acid that's left over. To get the concentration of the acid, we're going to take the moles, which is what we're in right now, divided by the total volume. Now the total volume, we had 25 mils of acid and 10 mils of base, so 35 mils, so 0.035 liters. So the concentration of acid, 0.043 molar. Since that's a strong acid, that's also the concentration of H3O. So to get the pH, take the negative log of 0.043, and the pH of this solution — 1.37. After you add 25 mils of 0.1 molar NaOH, you've reached the equivalence point because all of the acid and all of the base have reacted. The next problem, though, we want to find the pH of the solution after we've added 26 mils of 0.1 molar NaOH. Just like before, I need to find the moles of acid and the moles of base. So moles of acid. We have 0.1 molar. Its volume is 0.025 liters. For the base, we have 0.1 molar NaOH. and the volume is 0.026 liters of the base. So there is the amount present for the acid in the base. Now we're going to go to our reaction. HCl plus NaOH forming the salt and water. At the start of the reaction, for HCl, I had 0.0025. For the base, I had 0.0026 moles. Salt was 0. Change. Well, in this case, the HCl is going to be used up. So after the reaction is complete, there are 0 moles of HCl remaining. So the change is 0.0025 for all species, because again of the 1-to-1 mole ratio. So for the base, I have 0.0001 moles present after the reaction, and for the salt, 0.0025. But again, the salt comes from a strong acid and a strong base. The salt is neutral. It does not affect pH. The only thing that affects pH is the amount of NaOH present after the reaction. So we're going to calculate the concentration of NaOH by taking the moles divided by the total volume. Now the total volume is 25 mils plus 26 mils. Put that in liters, 0.051 liters. So the concentration of NaOH after the reaction, 0.002 molar. Since this is a strong base, that's also the concentration of hydroxide. So I can find the pOH by taking the negative log of 0.002. So the pOH comes out to a value of 2.7. And then the pH, 14 minus 2.7. pH is 11.3. Here's a table that shows data for this titration, and what I want you to notice is right around the equivalence point. The equivalence point is 25 mils of NaOH. But right around the equivalence point, the pH changes drastically. 24.99, the pH was 4.7. At 25, the pH is 7. And at 25.01, the pH jumps up to 9.3. So the pH changes drastically right around the equivalence point. Here's a titration curve for this reaction, titrating HCl with NaOH. A titration curve plots pH versus the volume of base added. What I want you to notice for this titration curve is the pH again changes drastically right around the equivalence point, which is 25 mils right here. I would want an indicator that changes color somewhere on the steep portion of this curve. So I would want an indicator that changes color somewhere between, looks like about 4.5 to about 9.5. So any indicator would work as long as the indicator changed color from around a pH of 4.5 up to 9.5.